Welcome back for engineering visualization channel. So today we are going to see another type of problem in section of solids. So in this today's problem, it is on the square prism. Okay, it is of different type. You can see we have go through the question now. So in the question given is a square prism of base heads 40 mm and length 60 mm, stand with its base on HP, such that all the rectangular faces are equally inclined to VP. So the meaning of rectangular faces are equally inclined to VP means it is nothing but all the edges for equally inclined to the VP means it is resting with the corner position. So remember it. So if in the question they have given all the rectangular faces are equally inclined to VP means your first position. So resting position, resting with corner position. Okay, resting with corner position. So it is cut by a section plane perpendicular to VP such that true shape. So in this problem they have given true shape is a rhombus of longer diagonal 75 mm. So in this problem they have given the true shape. Using the true shape we need to find out the front view, sectional top view and true shape of the section, and finally we have to find out the inclination of section plane with HP. So first we are going to construct the top and front view. So here in this problem it is resting with the corner position as we understand. Okay, so first I am going to construct XY line, X, VP, HP and Y. So we'll take a reference point here. Okay, now we'll take the protractor. So marking at 45 degrees on either sides. Now the length we should mark, that is 40 mm. You can see here base edge it is 40 mm. So we take 40 mm to mark at 40 mm. So 30, 40. Okay, 10, 20, 30, 40. Same way here also. 20, 30 and 40. Then take compass, measure 40 mm. Cut the arc. Okay, so here it is exactly cutting at this point. Okay, so since it is a prism, so we can mention both the top view notations and bottom view notations. So top view notations are ABCD and bottom face notations are A1 B1 and written within brackets. This is 40. A, B, C, D, A1, B1, C1 and D1. Now we will draw the thin lines to find out the center point of the axis. Okay, so that is, this is O and O1. Now we construct the front view. So for the front view we need to draw the projection lines. Okay, here axis length they have given 60 mm. 60 mm you can count 6 boxes, or you can draw 60 mm using the scale. Okay, this is 60. Now we can mention the namings here. A dash, B dash, C dash visible, but D dash not visible. Same way A1 dash, B1 dash, C1 dash visible, D1 dash not visible, O1 dash and O dash are not visible. Okay, now here we should draw a they have given in this question that is true shape of the section is a rhombus of longer edge, longer diagonal of 75 mm. So what we have to do is, here we need to make sure we should draw a line of length that is 75 mm. It should be marked on this. Okay, 75, you can say here, yeah, like this. You can take yeah, see here 10, 20, 30, 40, 50, 60, 75. So 75 it is exactly cutting here. So you can mention line, two smaller lines, bigger line, two smaller lines, bigger line, two smaller line. This is how we indicate the section plane, correct? And then the thick line at the end. So here can mention this is your yes, and this is yes. Okay, this is done. Now here, now after cutting these points, you can mention the cut points where it is cutting. This is cutting at 1 here, and here also 1, and 2 it is cutting here, here 2. So 3 it is cutting here, 3, and 4 it is cutting here, this is 4. Okay, so now, so this is what your the sectional top view. Okay, can I hatch it? Okay, so now I'm going to mark to draw the rhombus here. So here you can mark for 90-degree points. You can mark for 90-degree here, 90-degree points, and then you draw two lines here. Okay, here also we should mark points for 90-degree. Okay, okay, so this is done. Now what you can do here, parallelly you can draw another line. This is x1, this is y1. Now by measuring this lens, okay, measuring the lens, we can cut the arc. So we can measure it from here. Okay, this is 1, this is 2, this is 3, like that we can measure and cut it. Okay, so the first length what we have here, from here to here, this is 1 and 3 will be the same. Okay, 1 and this is 3. So we need to measure the point number 2, 2, no, 4.1. Like it is very less. Okay, you can just mark it approximately. Okay, this point is 1 and this point is 3, this point is 2 and this point is 4. Okay, now we can join all these points to form a rhombus. Okay, this is the procedure whenever they give true shape is a rhombus of dimension 75 like this. This is what the procedure you have to follow. Okay, then you can add it. Okay. So here this is true shape of section, and this is the rhombus. Okay, and this is your sectional top view. Okay, so now we have to find out the angle. You can see here they have given find inclination of section plane with HP. So that thing we have to find out. Here the angle we can get here, it is around 42 degree. Okay, the angle here, the theta what we get, that is 42 degree. So this what completes the problem. You can subscribe for the channel and hit on the like button and share it to the maximum students so that they can be benefited. Okay, this is one of the problem in section of solids, and it is beneficial for the uh, semester 3 or semester 4 students of the mechanical. So thank you all, thank you for watching the video.